Are you ready to unravel the mysteries of graph neural network and pin or physics informed neural networks for stock market prediction? So today we will introduce you to the powerful world of graph neural networks and physics informed neural networks, and will explore how they are revolutionizing this stock market analysis. So let's get started with graph neural networks. Now these graph neural networks are a type of neural network designed specifically for processing graph structured data. In the stock market domain, graph neural network could be used to analyze the relation between different financial entities such as stocks, bonds, and commodities by modeling the connections between them as a graph. Now, this graph consists of nodes and edges. So, in the stock market domain, nodes can represent stocks, bonds, or other financial entities, while edges can represent the relation between them. For example, an edge between two stocks could represent a co-movement between their stock prices, indicating that their price moved together in a similar manner. So a simple technical example of a graph neural network in the stock market domain could be a model that predicts the future price of a particular stock based on its historical price data and the prices of other stocks that are connected to it through edges in the graph. Now, this graph neural network would process the graph structure data by propagating information from neighboring nodes or other stocks to the target node or the stock whose price is being predicted through the edges in the graph. So, this graph neural network would then use this information to make the prediction. In this way, graph neural network can capture the complex relations and dependencies between financial entities, which can be useful for tasks such as stock price prediction, portfolio optimization, and risk management. So by leveraging the power of neural networks to learn from the structure of data, graph neural networks can provide more accurate and insightful predictions in the stock market domain. So let's understand physics-informed neural networks now. Now, these physics-informed neural networks are a type of neural network that incorporates physical laws and constraints directly into the network architecture. And by doing so, this physics-informed neural network leverages the strength of both neural networks or their ability to learn complex relations from data and physics-based models or their ability to provide physical insights and make predictions outside the training data. In the stock market domain, a simple example of physics informed neural network could be a model that predicts stock price movements based on the fundamental financial data and economic indicators, while also incorporating physical constraints on the stock price. So consider a stock whose price is influenced by its revenue and earnings. So here a pin could be trained to predict the future stock price by learning the relation between revenue, earnings, and stock price. However, in the stock market, stock prices are limited by various factors such as company fundamentals, market conditions, and investor sentiment. So these factors can be modeled using physical constraints, which can then be incorporated onto the pin architecture. So first it will have a input layer. So here the input layer takes in the raw financial data, example revenues, earnings, and economic indicators, example GDP growth, interest rate, and converts them into a format that the neural network can process. Then it has some hidden layers. So one or more hidden layers will process this input data using learnable parameters of weights and biases. Now these layers uses mathematical operations, that is dot products and activation functions, to transform the input data into a representation that is useful for the task at hand. And finally, it has an output layer which takes the transformed representation from the hidden layer and produces a prediction. So in this case, the output would be a predicted stock price for a given time period. Then we have some physics constraints. So in addition to the standard neural network architecture, PIN incorporates physical constraints into the model. For example, the predicted stock price may be constrained to lie within a certain range, say lying between the 0 and 1000, or follow a specific trend. Example, a decreasing trend if revenue is decreasing. So these constraints are incorporated into the loss function, which is then used to train the network. So by incorporating these physical constraints, the PIN network learns to balance the learned relation between the financial and economic data with the physical laws that govern the system. And this results in a model that not only makes accurate predictions but also provides physical insights and can be used to extrapolate beyond the training data. So in summary, we can say PIN or physics informed neural networks are a powerful tool for integrating physical knowledge into the machine learning models, particularly when the relation between the input and output is complex or unknown. And they have the potential to provide valuable insights and accurate predictions in various domains, including the stock market. So let's understand it better using a Python code. Now this code will demonstrate how to create a PIN or physics informed neural network using the Python libraries TensorFlow and Keras. So here the PIN is used to solve a simple mathematical problem and demonstrates how to apply physical constraints to the model. And the same approach can be used for stock market analysis. And the process can be broken down into several steps. In the first step, we will install necessary libraries. So where the script starts by installing the required libraries, TensorFlow, Keras and NumPy if they are not already installed. So after installing them, you will define the PIN model architecture. So where a function PIN model is defined that takes an input, waits and returns a output. Now here the function creates two dense layers with 10 neurons each, followed by a third dense layer with 1 neuron. And the output is then multiplied by exponential term controlled by the weight W2. Then we define the model, compile it and train it. So here the model is defined using the PIN model that inherits from the tf.keras.layers.layer class. So the class defines 3 dense layers with 10 neurons each and a weight W2 that controls the exponential term in the output. So this PIN model instance is added to the Keras sequential model. And then the model is then compiled using the Adam optimizer and the mean square error loss function. So the model is trained for 100 epochs using the fit method with the early stopping or after 10 iterations without improvement. Then we will visualize the results and learn the weights. So finally, the trained model is used to generate output for a set of input data and the results are plotted using matplotlib. So here the learned weights are also printed for inspection. So this simple example can be extended and adapted for stock market analysis by replacing the mathematical problem with the suitable differential equations and incorporating the necessary physical constraints such as supply and demand, sentiment analysis, and technical indicators. So the trained PIN model can then be used to predict stock prices or identify trading opportunities based on the learned pattern. So after running this code on the Google Colab, you can see the results like this. Okay, thank you.